like the linear function, quadratic functions, cubic functions, exponential functions, and logarithmic functions. Okay, and also we are going to be talk about their domains and range as well. All right. So let's we have to talk about. I'm just going to revise. What is the domain? Yes, anyone? Anyone? What is domain? Yes, Ali Muhammad and Hamza. What is domain?
The domain is the value that you enter into in a function.
That is suitable input values. And we have two types of domain. First one, that's known as natural domain, and the second one is restricted domain. The natural domain means when you are going to be situating the function, if you have any function, so the real domain and range are known as natural domain. For example, if I'm going to be write the function f of x is equal to 3x plus 1. So look at here, I'm just going to be write any linear function. Linear function, you know that it shows a straight line. So in a straight line, you know that every number you can substitute as an input and all the numbers as well as your output. So the domain of the range, domain and range of this function will be x belongs to all real numbers. That is your domain, and you have f of x belongs to all real numbers as well because the output is all real numbers. So it is your range. On the other side, if we are going to talk about the restricted domain, let's we have to take the same example. So if I'm going to say that you have to take a domain, I'm just going to be restricting a domain that if you have a domain is x is greater than equal to 0. Okay, you have to substitute all the values that are greater than 0. Now, what will be the effect on the range of this one? Yes, anyone? What will be
F
the
of
range of
x
this
is
function?
greater than or equal to.
Yes, you are going to be get the range will become f of x is greater than equal to because if you substitute 0, it will say is 1. If you substitute 1, it will be 4. And so, in the same way, you are increasing the value, you will get the answer. So, that's why it is known as restricted domain. I'm just going to be recall these things. Now, you have to go for the main topic that is the graph of functions and their domain and range. First of all, we are going to be talking about the linear function. I'm just going to take the same example I'm talking about linear graph. The shape of the linear graph is going to be look like a straight line. If you have any graph like y is equal to mx plus c in this format, this is basically always a straight line. And in the straight line, your domain is always because in this one you can substitute all positive values and all negative values. So in this situation, the domain is like the same example, you have all real numbers and the range is Actually, I've tried it as f of x. And range is all real numbers as well. The second function that we are going to be talking about, that is a quadratic graph. The shape of the quadratic graph is going to look like f of x is equal to ax square plus bx plus c. Means an equation, a function in which the maximum power of a variable is 2. Such type of function is known as quadratic, in which in the last class we have discussed the two situations. If you have a coefficient of x square is greater than 0, then the shape of the graph is going to be upright. And this is your turning point. And if the coefficient of x square is less than 0, means you have a negative value minus 4x square like this, then the shape of the graph is going to be upside down. Now, if examiner gives you any type of quadratic graph and you want to be simplify them, how you can do it? For example, if I'm just going to be writing the function into the completing square form, okay? For example, examiner gives you the function f of x is equal to x plus 4 whole square minus 3. Now, this is a quadratic functions, and we have to be talk about their domain and range, and we need to be draw their graph as well. Yes, Ahmed Hamza, can you please tell me what is the turning point here?
Turning point here is minus 4, minus 3.
The turning point is minus 4, comma, minus 3. Now, the coefficient of x here is going to be a positive 1. There is a positive sign. So the shape of the graph is going to be upright. Let's see how to draw the graph. Okay, before we have to draw the graph, we need to find the x-intercept and y-intercept as well. X-intercept, and we are talking about y-intercept. Y-intercept
Intercept
is
is
very
13.
easy. Sorry,
It's 13 or intercept.
minus 3. Which value you're talking about?
No, I mean the y-intercept is equal to y is equal to 13.
Not 13, it's minus 3. It is minus 3, 0 comma minus 3. You have to substitute x is equal to 0.
It's 4 square, it's 16 minus 3 is equal to 13.
Oh, sorry, my bad. My bad, my bad. Yeah, you are right. You are right. My bad. It is going to be 30. So I'm going to be taking it in a point 0 comma 30. Now I think there is no x-intercepts. Let's check. Let's substitute. We are going to be substitute y is equal to 0. So I'm going to be get 0 is equal to x plus 4 whole square minus 3. Minus 3 on the side will be plus 3, taking a square root on both sides. I need to remove a square, so I'm going to be taking a square root on both sides. So I'm going to be get x plus 4 is equal to plus minus square root 3. Now take this value on the other side. It will become square root 3 minus 4, and x is equal to minus square root 3 minus 4. 1 second, let's see how to check about the graph of this one. Huge graph. All right, now we have bracket x plus 4 outside there is a whole square minus 3. This is the graph we are going to get. Look at here, we have find turning point, that is minus 4 comma minus 3. This is the x-intercept, so obviously in which you have to take the one positive value and one negative value. It will be minus square root 3 minus 4. It will be square root 3 minus 4. And the y-intercept is going to be goes up. I'm not talking about that one. So this is, you have to draw the graph of. Okay, now in which the main point is that how you are going to find the domain and the range of this function. Just look at the graph and anyone tell me what is the domain and the range of this function. What is the
Domain
domain
is
of
real
this function? Sorry?
real numbers.
All real numbers, because in this function you can substitute all type of real numbers. You have to substitute any negative value, any positive value, you can substitute as zero as well. So all real numbers are going to be in the domain of this function. Now let's see how to talk about the range of quadratic graph. Yes, what would be the range? What would be the
If
output of this function?
x is greater than or equal to minus 3.
Yes. Look at here, we are talking about the y values because we are talking about the range. So here it is going to be upright. So we have take all the values that are greater than the turning point. Okay. For example, if it is upright down, so we have to take all the lesser values of the turning point. But in this case, we have the graph is upright down, so the smallest value is minus 3, and all rest of values is greater than 3. So we have to say that the range of this function is f of x is greater than equal to minus
3 minus 3.
3. Yes, everyone. Any question about the quadratic graph?
Mm.
Yes, anyone? Yeah, the Rahaf Ahmed. Ahmed Hamza.
No, Mr. Clear.
Yes, Ahmed Muhammad.
Mister, I did not understand the range.
Sorry?
I did not understand the range.
And this part you do not understand? From where you did not understand that you don't know how to find a turning point, x-intercept and y-intercept, or you don't know how to find the domain and the range.
Mister, he said the range.
The range?
Yes, he said that.
Yes,
The
he said
range
that we
is
need to understand
basically,
it.
the range is all the values that are going to be, look at here, I'm just going to draw the graph. the minimum point I told you, if you are going to be in the last lecture, we are talking about the quadratic graph in a very detail. If I'm just going to be go up on the graph, we have to talk about the quadratic graph here. It goes here. Here we are going to be talking about the quadratic graph in a detail, that how you are able to sketch the quadratic graph. All right, we have to draw the x-intercepts, y-intercepts, and turning point. And after that, I'm going to be also tell you, for example, if you have any type of quadratic graph, the shape of the graph, or if a is greater than 0, the shape of the graph is going to look like this. If it is lesser than 0, then the shape is upright, side down. If it is greater than 0, then this turning point is also the minimum point, because you will not get any value that is going to be lesser than this point. For example, if this value is 4, so you will not get any single value that is going to be lesser than 4. In the same way here, it is going to be a maximum value, because it is upright down. You will not get any value that is going to be greater than this turning point. So this turning point is also known as maximum point. For example, I'm just going to be taking an example. Let's say you have -2 and -4, and I'm going to be taking this one as -2 and -4 as well. If we are going to be talking about the range of this function, what we will say, the range is, it is -4, and all the values are greater than -4, right? Because it is y-axis. So -4 and all the values are greater than -4, so the range will be greater than equal to -4. On the other hand, if we are going to be talking about here, it is going to be a maximum point. Means all the values are lesser than 0 of the function. Look at here, this is lesser than value, this is lesser values. So here we are going to be talking about the range. If f of x is lesser than equal to all the values that is going to be lesser than equal to -4. So if you are going to be talking about the domain and range, so for in the quadratic function, so we have to look for the turning point. And obviously we have to look for how it is, the graph of is going to look like. It is going to be upright or it is upside down. Yes, Ahmed, right? It is clear. Ahmed Mohammed.
Yes.
So that's why look at here. We are going to be talking about the quadratic graph. So look at here. This is the turning point, and the graph it is upright. So we have to take all the values that are greater than -3, because you will not get any value that is lesser than -3. That's why I'm going to take that, because the y-axis is basically your range line, and the x-axis line is basically your domain line. So all the values that are greater than or equal to -3 is the values that are going to be the range of the function. Now, the next we are going to be talking about the cubic graph. The cubic graph are going to be look like f of x is equal to ax cube plus bx square plus cx plus d. Means in which the maximum value of the variable is going to be 3. Such type of graph is known as cubic graph. Now, in this one, we have two cases. The one case, the first case, if you have the coefficient of x cube is going to be greater than 0, and the second case, you have the coefficient of x cube is lesser than 0. If it is greater than 0, then the shape of the graph is going to be look like this. And for example, if you have a coefficient of x cube is less than 0, the shape of the graph is going to be like this. This is the shape of the cubic graph. You can check it on the GeoGebra, for example, so I'm going to draw any graph. I'm just going to simple graph x raised to power 3. So look at here, it is going to be like this shape. If I'm going to just write a negative sign with it, so look at the change. Now it is from left to right. First it is right to left. Now when I'm going to writing a sign, it will be from left to right. So always remember the general shape of the cubic graph. It is going to look like this. It is moving upward, it is moving downward like this. So if we are going to talk about the domain and the range, let's I'm going to draw the grid. The shape, I'm just drawing any rough sketch. Let's say this is the graph. If I'm going to talk about the domain, yes, anyone, what is the domain of this function?
Or real values.
Yes, in this function we can substitute all type of real values. So the x belongs to all real numbers. What is the range of this function? What is the output? Yes, what is the output of this function?
Also real values.
It is going to be all real numbers as well, because look at here, all positive x values and you are getting to be all negative x values. This means that the range of this graph is also all real numbers. I'm just talking about a basic graph, simple graphs. For example, if examiner gives you any simple quadratic graph or cubic graph or reciprocal graph, so you must have to know how the shape of the graph is going to be look like. All right. You can check it on the GeoGebra, and obviously you have to memorize it. For example, what change I will do and how the graph is going to look like. Okay. You must have to know the general shape of the graph. Now, after that, we are just going to be talking about the reciprocal graph.
Mr. Can you give us, I have a question. The domain of every cubic graph is all real values.
Yes, we could be graph, but obviously sometimes it is going to be restriction in the domain, and sometimes you have a cubic graph in which there is some changing. For example, I'm just going to draw the graph in which just simple basic AX cube like this. For example, if you have any specific values, for example, if I'm going to be substitute, just tell me any cubic graph, any cubic function.
3x cubed
3x raised to power 3
plus 5x squared
plus 5x squared
minus 9x
minus 9x
plus 7.
plus 7. Now look at here. Ultimately, the shape of the graph is going to be same like this, right? It is going to be a smaller change, but ultimately the shape of the graph is going to be look like the same thing from right to left. If I'm going to just change a small value, I'm just going to be changing the sign of the x cube. Look at here, it is going to be a change one. This from left to right now. A smaller, but ultimately the shape of the graph is going to be same thing. So look at here, in which you have all domains and all range. They are going to be the same thing. Yes, Hamza, is it clear?
Yes, it's clear. So also all the range will be all real values, right?
Yes. Because this is a graph, there is no reciprocal, because you are going to be getting the distinction if you have a variable in the denominator, if you have a square root. There is no such like thing here. So you can substitute all real numbers. Now we have checked that how the output is going to be look like. So it depends upon it. All right. Now we have to go for the reciprocal graph. Now the shape of the reciprocal graph is, reciprocal graph means the graph you are going to look like the variable is going to be into the denominator. All right. You have a variable in the 1 divided by, it can be 4 divided by x or 2x divided by 2 divided by x or any value divided by x. But the variable will be in the denominator. Such type of graph are known as reciprocal graph. Okay. In this one, basically, you will not get the value. If you have to substitute x is equal to 0, so you will get 1 by 0. That is undefined. Means this graph will not give you, it not give you any answer at x is equal to 0. Now, if we are going to talk about the general shape of the this graph is, it is going to be like this. From here, it is going to be closer to y values, but not touch it. And from here, it is going to be closer to x values, but not touch it. In the same way, in the third quadrant, it is going to be closer to y values and x values. This is the general graph of any reciprocal function. Let's check it. For example, you have to take 7 divided by x. Look at here. See it. In the first quadrant, it is going to be closer to y values, the y-axis, but it will not touch the y-axis. And here it is going to be closer to x-axis, but it is not going to be touch the x-axis because you are not going to get the answer will be 0. In the same way here in the third quadrant as well. So if you have to any reciprocal function, so the graph of the reciprocal function is always look like this. Now, if we are going to talk about the domain and the range of this function, yes, anyone tell me what is the domain of this function?
It's greater than 0. X is greater than 0.
Look at here, x is greater than 0. You are getting the negative values as well. If you are taking
Equal
only
to
the
0.
positive values, you
X
are getting the
X
negative
is
values
already
as well.
valid. X is already
All
values,
real number.
but not equal to 0.
Yes, you have all positive real numbers, you have all negative real numbers, but at this point, x is equal to 0, it is undefined. So we have to say that x is all real numbers, but x is not equal to 0. Now we have to talk about the range of this graph. Yes, range means the output, the y values. Yes. Anyone?
Uh,
Yeah.
X is
Look at the y values. Can we substitute? Can we will get all positive y values? Yes, no.
yes. So X is
Are we getting
already values, but
all
not
negative
equal
y
to 0.
values? All negative values, but we are not going to be getting the answer at y is equal to
0.
0 as well. So what we will say? So the range is this function is all real numbers except f of x is not equal to 0. This is a general shape of a reciprocal graph. Let's make a small change. It is a positive value. Let's make it a negative value. Now look at here when I'm going to make it negative value, the graph from first to third function, it is goes to the second and third one, fourth one. The reciprocal, you have a graph is a divided by x, and a is lesser than 0, means a negative value. For example, you have 1 minus 1 divided by x. The shape of the graph is going to look like, it will be in the second quadrant and in the fourth quadrant. The range and domain is going to be exactly the same, because look at here, you are getting all positive x values, all negative x values, all positive y values, all negative y values, except x is equal to 0 and f of x is equal to 0. All right. So here we have to take a function in which you have a is greater than 0, and if a is lesser than 0, then the shape of the graph is going to be in the third quadrant and in the fourth quadrant. Yes, everyone. Any question about the domain and range of reciprocal graph and the shape of reciprocal graph? All of you must have to memorize these shape, okay? Because without these shape in your mind, you are not able to tell about the domain and the range of these type of functions. Okay. Yes, everyone. Any question? Yes, Hayad, Ahmed, Ahmed, Ali Muhammad.
Clear.
Clear.
Now we are talking about the exponential function. Exponential graph. Having a variable in power or index. All right. Like you have a graph f of x is equal to 2 raised to power x. All right. You have a graph 4 raised to power x, 100 raised to power x, or any value having a power x. So how the shape of the graph is going to be look like? So let's see how to check. For example, 2 raised to power x. Now look at here. You are going to be getting the all real numbers in the y-axis, because it is slowly moving towards the, because you can substitute all type of values, all positive x values, you can substitute all positive and negative x values as well. The graph is going to be look like this. If you are going to be looking like this line, look at here, it is not going to be reached to the y-axis. It is going to be very close to y-axis, but it will never reach at the x-axis. It will not touch it here. All right. If I'm going to zoom out, it is going to look like that. It is going to be from x-axis, but it is not on the x-axis. It is above the x-axis. Yes, everyone, it's clear. You can take any variable. It's not necessary that you have to take raised to 2 raised to power. You can take any number raised to power. Let's say you have to take 100 raised to power x. The shape of the graph is going to be still like the same thing. Yes, everyone. Any question?
Clear,
Yes,
sir.
everyone. So I'm going to make a general graph the graph of this function is going to be look like. It is exponentially increasing basically, and it is going to be closer to x-axis but will not touch it. All right, the graph of any exponential function. Okay, we have 2 raised to power x. In the same way, we are going to be talking about another exponential functions, right? E raised to power x. E is a specific number basically. So I'm going to be told you the E has a specific value that is 2.71828. It is known as E or exponential. Okay. So if you want to be draw the graph of this one, so it is going to be the same like that thing as well. You have E raised to power x. You have to iterate. So look at here, the shape of the graph of this one is going to be the same as well. So all this type of function is, let's have it right here. It is going to be also the graph is going to be look like this. And from where these points are going to be passes, this point is 1. Because at x is equal to 0, the you are going to be any number having a power 0, that is 1. Yes, everyone. Can you please tell me about the domain and the range of this function? Which values you can substitute in this function?
Or real values.
We can substitute any real values, all positive values, all negative values, so all real numbers. What is the range of this function? Yes, range means y-axis values.
F of x is greater than f of x is greater than 0.
Because you are not going to be getting any values in the negative on the y-axis, the negative y value. You are going to be not getting the values on the x-axis as well. It is all the values that is above the x-axis, means all the values that are greater than 0, not equal to. Because if it is equal to, it means that this graph is going to be touch the x-axis. So all the values f of x is greater than 0. Yes, everyone. Any question? Yes, everyone. Any question about the graph?